Okay, how about now?
Okay, now it's recording. Yeah, it's recording now.
Okay, perfect, perfect. Okay, so the chain rule. We have, basically, we are going to have composition of functions to worry about when we talk about the chain rule. So let me just read this to you and then I'll explain it. If g is differentiable at some x and f is differentiable at g of x, so that's the composition, then we can say f equals f composed with g is defined by f of x equals f of g of x and is differentiable at x, and f prime is given by this. So basically what this says is, if I have a composition of functions, I take the derivative, because it's going to look like this, right? I take the derivative of the outside function times the derivative of this inside function. G of x is the inside function, okay? So I haven't really worked yet with the Leibniz notation. I personally like it better in general because it gives me an idea of what exactly I'm taking the derivative of, okay? And what this means is I'm taking the derivative, so this right here means I'm taking the derivative of y with respect to x. This means I'm taking the derivative of y with respect to u, and here I'm taking the derivative of u with respect to x. And if you notice, this is a chain rule because even though these are two derivatives on the right-hand side, if you think about it like you can, like fractions, you can actually see that you can cancel those du's and you end up with dy over dx, which is what you're looking for. And I know you don't know how to apply this yet, but I just wanted to show you the basics of the two different kinds of chain rule. Okay. I'm not even going to go over this. Let's go do a problem so that you can kind of see what I'm talking about. So let's do it. I'm going to do it two different ways. I know that if I say this is f composed with g of x, then that's going to equal f of g of x, right? So can anyone tell me what f of x is?
Would it be sine x?
Yes. Well, f of x would be sine of, um, sure.
Sine
Would
of
it,
u? Sine of u?
well, it would kind of be actually, let's leave that for a minute because let's find out what is g of x. Thanks. That was Soraya, right?
Yeah, it was me.
You're not really wrong, so I don't want
Mm-hmm.
to say you're wrong, but what would be g of x?
X squared minus 4.
X squared minus 4. So what would be f of x? It would be really sine of g of x, right?
Oh, yeah, sine of g of x. Okay.
That's kind of what I mean. So if we say this, let's say this is equal to h of x, right? So this is the one where we're taking what the one up the format I'm using right now is this one. Okay, where I'm finding the f and g and I'm taking the derivative of f of g of x times the derivative of g of x. Okay, so I can say that what's the derivative of g of x? Let's do it that way.
2x.
2x, right?
2x.
Good, good, good. And then I think I should write this as, I think might be more clear if I write this as x squared minus 4. And then if I say, what's the derivative of f of x? What's the derivative of f of x if I say that x squared minus 4 is another function? I guess that's what I want to say. Um,
Would it be cosine x squared minus 4?
yeah, thank you. It would be so if I say that f of x is equal to that, this is not really true. This is really, okay, I have a better way to write it. Sorry. So sorry, I don't mean to confuse you. As you can see, this is not my favorite way to do chain rule. So this would be f prime of g of x. That would be more in sync with what that formula is. Okay? Okay, now let's just stop here for a second. Does that make sense to everybody? Where did it happen to my, oh, there it is. Does that make sense so far to everybody?
Yep.
Yes?
Yes.
Okay, good, good, good. So now if I want to find h prime of x, it's going to be equal to f prime of g of x times g prime of x from that formula that we had on the previous page, right? So we know what f prime of g of x is. It's equal to the cosine of x squared minus 4. And then we have to multiply this by g prime of x, which is 2x. And my answer becomes 2x cosine of x squared minus 4. Okay? So this is one way to do it. And let's just look at it again really quickly. So if I say, let's say h of x is equal to the sine of x squared minus 4. And I want to know what h prime of x is. Well, first I look at the outside function. The outside function is the sine. And the derivative of sine is cosine. So I would write cosine of x squared minus 4. And then I'm going to then multiply by the derivative of the inside function. The derivative of the inside function is 2x. So I get 2x cosine of x squared minus 4. That's what we just did. Okay? So I'll stop here for a minute and take any questions if anybody wants to ask a question. Then I'm going to do it a different way. I'm going to do it with substitution, which I think I personally makes more sense to me, but it may not to you. So I'm going to show you both ways. So is that clear what we did here? Does anybody have any questions? And again, learning the chain rule is probably the most important thing that you're going to do this semester. I mean, there's other things, but we have to know how to do chain rule. Okay, so has everybody got this copied? I'm going to erase it because I want to show you a different way to do it. Okay.
Yeah.
Okay, so I'm going to erase and we're going to start again. Okay, so I'm going to just start with this function right here. And we'll just call it h of x. And I noticed that inside function is something more than x, right? It's not just x. If it was just x, I don't have to do anything. But since it's more than x, I'm gonna say, let's let u equal x squared minus 4. And then I can say h is equal to sine of u, right? Does everybody see that so far?
Yeah. Yeah.
Okay. Very good. Now, what I want to find, now this is where things get a little, like we haven't used this before, so it's not that it's complicated, but we haven't done it this way. I'm going to use that Leibniz notation, and I'm going to say that the derivative of h, or h of x, with respect to x, is what I'm trying to find. Because h of x is the function, and the independent variable is x. So that's what I'm looking for, is the derivative of h with respect to x. Okay? But here, if I look here, let me get different colors. So if I look here, I can say that the derivative of u with respect to x is equal to 2x. Does everybody understand that?
Yes.
Okay, everybody? And then for h, I can say the derivative of h with respect to u, because h is the dependent variable and u is the independent variable. Well, that's equal to the cosine of u. All right. Now, I want to know what dh dx is. And I have dh du. And if I multiply that by du dx, notice I would have that thing where if I cancel those du's, I would end up, I made a mistake. That's du dx. This is du dx. This is du dx. Now, if I cancel those du's, notice I have dh dx. So all I really have to do is look at my dHdu, which is cosine of u, and I'm going to multiply that by du dx, which is 2x, which gives me 2x cosine of u, but u is equal to x squared minus 4, so I have 2x times the cosine of x squared minus 4, which again is the answer that we've gotten that answer a couple of different ways now. Okay, so probably the first way is a little bit easier to do once you get the hang of it for this function. But if what you can have is a few embedded functions, and when that starts to happen, you can get lost very quickly. So I'm trying to show you this way because this way will not get you lost and the other way will. All right, any questions here?
Yeah, I got a question.
Yes, sir.
So with dh over dx equals like the second, or I guess third line where you started, I kind of got lost right there.
Right here. So
Yeah.
we want to find, so here's our original function, right, up at the top. So what I want to do is I want to find the derivative of the derivative of h with respect to x, because this one has x in it, right? This is what I'm trying to find. So that's why I put that there. This is the answer. If I know what that is, I have the answer. But I don't know what that is because I have this chain rule. And here, notice I found, so do you understand what's in red up at the top? U equals x squared minus 4h.
Yeah.
Good. And then you understand here, what I said here is the derivative of each one of those.
Yeah.
So what I want to do, the chain rule basically is I'm going to chain those together. So if I want to find dh dx, which is what I said I wanted to find, I have already, here, do I have a pointer? Let me see, I think I have a pointer, yeah. So I already have du dx, right? And I have dh du. And notice if I multiply those together, it will give me dh dx. Are you seeing what I'm showing?
Oh yeah, I thought you just.
That's all I did, because I'm given these things, I want to multiply them together. That's going to give me dh dx. And then I know dh du is this cosine of u because I wrote it here. And I know du dx is 2x because I wrote it here. I just multiply it out. Then I substitute the u, which is here, inside, and I'm done.
So in yellow, you didn't cancel anything?
I did. I'm just showing you that if you think about these as fractions, and I could cancel that, which I'm not going to do. I can't do that. But if I could, notice how I would get dh dx, which matches on both sides. Okay, so let's just do some more, and then I'll give you, if I don't have one already in the PowerPoint, then I'll make up a really long one, and I'll show you why this works better than the other way. Okay?
All right.
Okay, let's do another one. Oh wait, did I have? I guess somewhere it said something about what that equals. That's okay. We did both ways, so I'm not gonna. So the most common mistake whenever you do a derivative is to use the chain rule. Every derivative problem could be thought of as a chain rule problem. Every one of them. So let's say I want to take the derivative of x squared with respect to x. That would be 2x. And if I think of this x squared as my inside function, okay, like I could say let u equal x. We wouldn't do this, by the way. And then let y equal x squared, u squared. Then if I do it, basically, well, no, I don't want to do it this way. If I have this right here, and I use the first one where I take the derivative of this times the derivative of the inside function, can you all see that? Can you all see that if I do that, what I would get would be 2x, which is the derivative of this. And if I call x the inside function, I would say the derivative of x with respect to x. And the derivative of x with respect to x, I could also write it out like this, always equals 1. So even though we don't consider this a chain rule problem, again, every problem is a chain rule problem. Okay? We'll see that again when we get to implicit differentiation. Okay. So chain rule for powers, again, it's n, just like the derivative, if you have g of x to the n power, and you just have x as a thing. Let's say g of x equals, let's say g of x to the nth power is always going to be n g of x to the n minus 1, right? But notice now, if we say g of x could be something other than just some x value, then we also have to take the derivative of that inside function. So for example, well, okay. Now this is really going to be confusing. So who can tell me what the answer to this is? Who wants to give it a shot? Not Soraya.
Can I give it?
Somebody.
Can I give it a shot?
Yeah, is that Nick?
Yeah.
Yeah, Nick. Yeah, I'd like you to give it a shot. So I want to find the derivative of y with respect to x, or we could say y prime. They both mean the same thing. Okay. How would you tackle this?
Y prime. Find your inner and outer function.
Okay. So what's my inner function?
Inner function would be
What am I
sine of x.
What is it?
Would be sine of x.
Yeah, inner function is sine of x. Good. Outer function, we'll call that f of x, is
X to the 7th power.
Well, if we call this g of x, it would really be g of x to the 7th power, right?
Yeah.
Okay, good. Now, how would I find the derivative?
Hold on, I'm copying one.
Yeah, no worries.
Would we use that chain rule?
You have to use a chain rule always.
Okay.
Chain rule always exists, even when you don't know it exists. It
We
exists.
want to make the derivative of f of x and derivative of g of x.
Okay, what's the derivative of g of x?
It would be cosine x.
Okay. What's the derivative of f of x?
F of x would be 7 times g of x to the 6th.
Okay. Good. And so how do you put this together?
So you have like y prime is equal to, and you'll have the derivative of f of x, which is 7 times g of x to the 6th. And you have to just put in that g of x, so it'll be sine of x where g of x is.
Well, in a minute. Yeah, we'll do that in a minute. Let's just keep going. We'll put that in. I think it's easier to do it like this for the moment.
Okay, and then you multiply it by g prime, which would be cosine.
Okay, good. And so the next step would be 7, and we know g of x is equal to sine of x. So let's say sine to the 6th of x times cosine of x. That's perfect. That's exactly correct. That's doing it that way. How about if we do it the other way? How about if I say, and if anybody's not understanding, this actually is the same as that. Okay, so in case anybody's confused, let's just call that that. All right, so now let me change colors. Let me do it a different way. So now I'm going to let u equal sine of x. And I'll say y is equal to u to the 7th power. And now I can say du dx is equal to what?
7u6.
No, we're talking about the derivative. So the derivative of u with respect to x is the derivative of that. What's the derivative of sine?
Cosine.
Yes.
Cosine of X.
Cosine of x. And then I can say the derivative of y with respect to u is equal to what?
7u6.
7u to the sixth power. Now the chain rule says, and what am I trying to find here? I'm actually trying to find, here, I already wrote it. I'm actually trying to find dy dx. Dy dx is equal to, I have dy du, and I have du dx. And I notice that this works because the du's, if you think of it as a fraction, the du's cancel, and I have dy dx. So I can just plug it in now. Dy du is 7u to the sixth. Du dx is cosine of x. And then last step, I'll plug in what I have for u. So I have 7 sine to the sixth of x cosine of x. And of course, it's the same answer. It would have to be the same answer. There's just two different ways to do it, the same thing. And it's really your choice, okay? Is there any questions about anything here?
I'm good.
All right, this one looks a little more complicated. Does anybody want to give it a shot? Nobody? Okay, so first thing we're going to do is we want to look at what our functions are. So what's my inner function here? I'm going to do it calling it u, because it's really complicated to do all in your head like that first one is. So what would I call u here? I'm going to call you the inside function. What's the inside function here?
2x sine
2x
x.
sin x.
2x sine x, good. And then I'll call y, we'll call it tan of u. Okay? So far, so good?
Yeah.
All right, good. So how do I take the derivative of u? And that's going to be du dx, right? How would I take the derivative of u?
Is it 2 cosine x plus
I'll stop
no,
you
wait,
there.
wait. It's actually 2 sine x plus cosine x 2x.
2x cosine x, very good, very good. So you have to use the product rule, and we did. Is everybody okay with this? We took the
Yeah.
derivative of this times this, and then we took the derivative of this times that. Okay, and it worked out perfectly. Now I have dy du. And what's the derivative of dy du?
Is that secant squared x or secant squared u?
Secant squared u, exactly. So now I'm looking here, and I say I want to find dy dx, and that's going to equal dy du times du dx, right? So dy du is secant squared of u. Du dx is 2 sine x plus 2x cosine x. And then I'm going to have to substitute my u. So I have secant squared of 2x sine x times 2 sine x plus 2x cosine x. And I think I'll write it like that. And I think that's clear and sufficient. Is that clear and sufficient? Does anybody have any questions? Feel free. I know this is complicated until you get used to it.
Professor,
Yes, sir.
I did the problem with you before, and you see that I used the first method.
Yes.
How would you recommend I try and memorize? Because I use that f of x and g of x. How would you recommend trying to get into my head that that g of x is also
Use
like that.
substitution. If you use substitution, if you do it a few times, you're going to be better off, I think. Because as they get more complicated, it's way easier to keep track of everything,
Okay.
in my opinion. Now, if it's a really easy one, then I wouldn't say to use substitution. But when it's complicated, I would say to use substitution. So ask me the question again, because I'm not sure what your question is.
So I labeled basically the u is g of x. And
Okay.
f of x is tangent of u.
Uh-huh.
And so, but I originally labeled it g of x is equal to 2x sine of x, and f of x is equal to tangent of u.
Of g of x, yeah.
Yeah, and then so I don't know. I just
Did you get the same answer?
I did.
Yeah, it's fine. You don't have to do it my way. I do recommend that you learn this way. Just for the more, let me see if we have anything that's going to be more complicated. I don't know. Let's see. Let's just keep working. And if we don't get one very complicated in here, I'll make up one at the end so you can see what I mean by when things get complicated. Okay.
All right.
All right. So who would like to tackle this one? In any form you like, with using any method. Everybody should be trying to do this with me. It shouldn't always be Nick and Soraya, by the way, because you'll learn a lot by trying. Even if you don't get it right, it's okay. I can help you along. Does anyone want to give it a shot? Hey, Ethan, how about you? You want to give it a shot? No? Ethan? No, Ethan. Okay. Hey, Andy, call on somebody. I can't see all the names.
I'll go.
Who's that?
Brian?
Brian? Okay, Brian, let's give it a shot.
Hello?
All right, so I was gonna do substitution, right?
Whatever
So
you want. Yeah.
U's would be the inside function, so that's 3x,
Good.
and then what's it
So
called?
then
Y would be 2 cosine x.
2 cosine what?
Oh, U.
U. Perfect. Perfect. And then we want to do the derivative of u with respect to x, right?
Mhm.
What is that going to be?
That's gonna be 3.
Good. Oops. 3. Good. And then we want the derivative of y with respect to u. Sorry. And what's that going to be?
That's gonna be 2 negative sine
Of u,
U. Yeah.
right?
Mm-hmm.
Perfect. And then what am I looking for? I'm looking for dy dx because I'm looking back at my original and I can see that I want to take the derivative of y with respect to x. And what am I going to use? What am I going to chain together to get that?
Multiply du times dy.
Well, let's use what we have here. We're going to say d what?
Dux.
Du dx.
Du dx, I mean.
Uh-huh. And then
Dy du.
times dy du. Exactly. So du dx is 3. Dy du is negative 2 sine of u. So that equals negative 6 sine of u. But I know that u equals 3x, so I'm going to put that back in. And there's my final answer. Perfect. Good job, Brian. See, it wasn't too bad.
Yeah.
Is everybody okay with this? Any questions?
I'm still copying down.
Yeah, no worries. Take your time.
I'm good now. Thank you.
Perfect. All right, here we go. We can do this again. So, anybody? Any takers?
Please pick a random person again. I love it.
What? Pick a random person?
I love it.
You love that? Okay. Frank.
All right.
Unfortunately, I'll pick the people's names that I remember really well. So sorry about that. You there, Frank?
Yeah, I'm here.
You want to give it a shot?
Yeah, would you put it to the third power?
What is it?
Would you put the function to the third power first?
Not to the third. What would I put it to?
5 minus 7x squared.
No. Like, if you want to put it to a power, what is that power? It's not the third power. What is it?
To the 1/3? I thought it was to the 1/3.
It's 1/3 power. It's not the third
Oh,
power. It's 1/3 power. Think about the roots. They're going to make the number smaller, right? To the third power would make the number bigger.
Oh, that's what I meant. Like, yeah, to the 1/3, yeah.
Oh, okay. I thought you kept saying to the third power. Oh, to the
Yeah.
1/3 power. Oh, I see. Oh, that's interesting. I never realized they sound the same. Okay, you're right, Frank. Good.
Funny.
Yeah,
All right, and,
I thought you were saying like to cubed instead of like the 1/3. I understand. Okay. So now
would you make it a U and
Yeah, sure. Let's make what we call you.
5 minus 7x squared?
Good. And then what is y?
U to the 1/3?
Good. Good. And then what are we going to do next? I'm going to let you do the whole thing. I'm not going to try to help you.
All right, differentiate both of those.
So I have du, what?
Over D, I'm honestly bad with this notation, X, I guess.
Du dx. Du and x.
Okay, perfect.
Okay, and what's that going to equal?
0.
0?
Oh,
Not
5
0.
is 0. Yeah, 5 is 0 minus.
0. I'm just going to leave the 0 off. Okay. So what
then,
is
negative 14x.
perfect? And then I have what? What's the next thing? I'm going to take the derivative.
dy over du.
Perfect. And that equals
1/3 minus 1.
1.
I'm,
Wait,
I'm,
what?
I'm thinking out loud right now.
Okay. Tell me what you're
Uh,
thinking out loud, and then I could start writing.
well, now it's 1/3 or 1/3 u to the negative 2/3 power.
Perfect. And now what do we do lastly? That's all that's good.
Oh, my brain hurts.
What?
My brain hurts right now.
Good. That's good. That means we're making new pathways. If you go to and it doesn't hurt, did you do anything?
No, you're right.
Okay, so you're working. That's good. I'm happy that your brain hurts. Look, so what we're trying to find, so think about what you're trying to find first. The first thing you're trying to find is what? What would the derivative of this be in this Leibniz form?
Well, we're multiplying them together, right?
Yeah, but what I'm asking you is basically I want dy dx, right? That's
Oh, yeah.
that's what I'm trying to find. The derivative of y with respect to x. And that's
Yep.
going to equal, go ahead, tell me what it equals.
Du over dx times dy over du.
Good. And then we just plug it in, right? I mean, there's nothing to it. So we have minus 14x times 1/3. And I'm going to just substitute the u because I already know u is going to be 5 minus 7x squared to the minus 2/3. And then I can clean it up a little. This becomes, so I can do 14 over 2 is negative 7x times 5 minus 7x squared to the minus 2/3 power.
Perfect.
That's perfect. You did a great job, Frank. Don't be
Thank you.
afraid. Don't be afraid to participate. You know what you're doing. And if you don't, it doesn't really matter. I'll help you along.
Dr. Reaper, I have a question. Where did you get the 1/2 from?
The 1/2.
Yeah, and like the blue ink, it's like,
Yeah, that's interesting. I don't even know where I got the 1/2 from.
is
That
it
should-
1/3?
I
Okay.
think. So it becomes 14/3. Sorry about that, guys. You're right. See, I make mistakes like that too. I have no idea where the 1/2 came from. All right, any other questions? All right, now this problem, if I look at this problem, what I'm saying is this problem I would probably solve without the substitution because it's not that difficult to see the inside and the outside function. With trig functions, it's a little more tricky, honestly. So, Ethan, are you there? Do you want to give this one a shot this time? No, Ethan still. All right, Andy, can you call somebody's name? I'm trying to think of who's here. Shayo's here, right? How about Shayo? Is Shayo here?
Yeah, I'm here.
Okay, you want a shot?
Yeah, I'm ready. Okay.
Okay, good. It's okay if you get it wrong. Don't worry about it.
All right.
So, yeah, whatever. So what we want to do, which method do you want to do this with?
I don't know the method, but I know what I do to solve it.
Okay,
So I guess the inner is x to the x cubed minus 1,
okay, we'll just call it inner equals x cubed minus 1. Okay,
and then the outer is u to the 100th power,
okay, good.
and then you would solve for derivatives.
Okay,
So it would be 3x to the second power for the inner,
okay,
and
Okay.
u would be 100 u to the 99th power.
so, okay, so I guess we're doing it like this. Inner prime is equal
Yeah.
to x squared, and outer prime is equal to, what did you say it was? I'm sorry.
The 100th u to the 99th power.
Cool. Good. And then what would I do next?
This is where you do the dx over the dy thing, right?
If you're going to do it my method, I wouldn't do it like this.
Okay.
It's very close. I would just use variables. I wouldn't use inner and outer because it's just too long. I would say, let's let u equal x cubed minus 1, right?
Mhm.
And then I could say y equals u to the 100th power.
Right. Okay.
Okay, and then I could say I'll say du dx equals what?
Oh, so x cubed minus 1 over u. Oh wait, hold on. Wait, where'd the x come from? Oh,
Well, I'm taking that. So if I take the derivative of this,
uh-huh.
notice I have the derivative of what we call that is the dependent variable because it's what it equals, and then I put it over the independent variable, which is
Oh,
x. Because if I was solving this, we call x the independent variable because I can say x equals whatever, x equals 2. It's independent, but then u is dependent on that, right? Now u equals 7 if x equals 2. So we call it the dependent and independent variable. So I put the dependent over the independent variable, if you like those words better.
Okay, so it would be so u over 100 over 3x squared.
Wait, first we're gonna get the du dx. So we want to take the derivative of u right here.
Yeah,
And
that's
it's
3x squared.
like that. And what's that gonna be?
3x squared.
Perfect. And then I want to take what? The derivative of, I want to do this one.
U.
Derivative of which is on top?
What do you mean which is on top?
Well, I'm going to have a fraction, right? I'm going to write this du, like this du dx is a fraction, right?
Yeah, yeah.
So I'm going to have to take the derivative of this. How am I going to write it? Well, I'm going to write the dependent variable on the top. over the derivative of the independent variable.
Oh, okay. So that's what
See
you're
it?
saying. Yeah, okay.
Okay, good. This is important because we're going to get to something called related rates, and you really have to know what this notation means. So don't think that you cannot learn this notation. You really do need this notation. Okay, so dy du equals what?
100 u to the 99th.
Perfect. So now I want to find, so what am I trying to find here as far as this notation? What would be the derivative? What would be the notation for finding the derivative of the original function?
Du.
No, there's no u in the original.
Okay. Oh yeah. So the dx over, or dx times dy.
No, so whenever we want to find the derivative, so
Mhm.
this notation, d, let's call it this. This is also the notation for derivatives, but it would be the derivative. I'll just write it in words. The derivative, that's not how you spell it, a tiv of the dependent variable over the derivative of the independent variable. Yeah, you know how to spell it. Variable. Okay. So do you see here that what is the dependent variable in our original function?
U to the 100th. Yeah.
No. We're looking in the original function right here. Right here. This is the original function.
Mm-hmm.
Right? So if I want to find the derivative of that, what would be the dependent variable?
Oh, x cubed minus 1.
No. The dependent variable, like if I were to say, it's okay. Listen, you're helping everybody. Trust me, this is not common knowledge for people. So if I were to solve this, let's say I want to graph that, and I don't know what it graphs like, right? And I want to just start plotting points. What would I pick? What would I do? Would I pick an X or would I pick a Y first?
I pick an X.
You would pick an X, so would I, right? That means that since I'm picking X, that's my independent variable. I can pick whatever I want.
Right. Oh, okay.
Once I pick an X, let's say X equals 1, then I have 1 cubed minus 1, which is 0. 0 to the 100 power is 0. Is Y still independent?
No, it's dependent.
Now Y becomes dependent on what X equals, right?
Right.
So that's how I want you to think about this. We have the derivative of the dependent variable over the derivative of the independent variable. Okay. So for this one, I would say the dependent variable for y equals x cubed minus 1 to the 100th is what?
Oh, so it's d over dx. Okay.
dy over dx.
Yeah.
And that's going to equal, and now I go back to what I used for my substitutions. So what does that equal in terms of these two things that I found the derivative of over here on the right side?
So this, I would be like canceling them out pretty much.
Well, first we're going to say, so, I mean, it doesn't really matter. I know dy dx is going to equal dy du, because I have dy du right here, right?
Uh-huh.
And if I have dy du, I also have du dx. Let's just see. Oh, yeah, that works, because if I look at it and I cancel the du's, which you're not doing, you're not canceling them. It's a visual for like help you. Then can you see that if I cancel those du's, I would get dy dx equals dy dx, which is perfect.
Mm-hmm. Right.
See that?
Gotcha. Okay.
Okay, good. So now once I get to here and I've taken all my derivatives, I've done all my substitution, now it's pretty easy because I know dy du is equal to 100 u to the 99th power, right?
Mm-hmm.
And I know du dx is 3x squared. And then I just do one more substitution because I can't have that u in there. So I would say this is 100 times x cubed minus 1 to the 99th power times 3x squared. So I could say this is 300 x squared times x cubed minus 1 to the 99th power. And that would be my final answer.
Okay.
How did that go?
Well, it's new for me, so
Okay, good. Very good. Is anybody still copying this?
I'm good.
All right,
Wait, give me 1 second.
okay. Oh, we're still doing go time.
Okay, you're good.
All right, let's try doing this. Now the only way to do this is the first way, right? We can't do it the second way. This is a little confusing, so, oops, I didn't mean to do that, yeah. So let's see if we can get this, done. So we start out with h of x is equal to g of 2 plus f of x squared. And we want to find h prime of 1. So the only way to really do this one is probably the first method, not the one with the substitution, although you could probably get away with doing that, but let's just do it the first way. So does anybody want to give this one a shot? This one's a little more complicated. I'm tempted to ask Nick to do it because he's very comfortable with that first method, but anybody willing
To
to
be honest
volunteer.
with you, I got a lot more comfortable with the second one after following along with you. Like the second.
Okay, good. That's okay. I want you to be comfortable with both. I'm more comfortable with this, with the second method, honestly, but let's just do it because you need to have both possibilities. All right. So does anybody want to give it a shot? Well, let's kind of think about it. So we'll start here, and if I want to take the derivative of that, it's going to be equal to, well, the derivative of g of the function of the inside function, right, times the derivative of the inside function. And I'll just write it like that. Does that make sense to everybody?
Yeah.
Okay. Any questions from anybody? All right. So, well, we know, sorry, this, yeah. So I want to try to evaluate this first because I'm already done with that. I just need to find what that equals, right? Does anybody know how to do that? I'm giving all this stuff here at the top. So does anybody have any ideas? Well,
2x for f of x.
well, we know, don't we know what x is? We're trying to find h prime of 1, so x is equal to what?
1.
1. Good. So now I have 2 plus f of 1 squared, which is still 1, right? And I'll just write this down so we don't forget about it. Okay. So now we can find, well, what's f of 1?
Is 2.
2. So 2 plus 2 is 4, right? So we end up with g prime of 4 times 2 plus f of x squared. We're going to take the derivative of that in a minute. So what's g prime of 4?
-3.
There you go. So now we have -3. How do we take the derivative of this? So what's the derivative? So we have, what is it?
Sum rule?
Sum rule, good. So go ahead.
Hold on. You gotta. I don't have this one on my head, so I'm just going back to my notes to pull it back up.
That's okay. That's okay. Do whatever you need to.
So it said it's the derivative of f of x plus the derivative of g of x.
Okay, well, let's not use f and g because we already used f and g. We'd have to use something else. So if it's plus
The derivative of 2,
the derivative of 2, which is
0.
good, times the derivative of, so let's just write it again so that it looks less complicated. I mean, take as many steps as you need. So that's still true, right?
Mhm.
Okay, how would you take the derivative of f of x squared?
Find inner and outer function.
Yes, good.
So then your u would be x squared.
Okay, well, we're not going to do u's probably for this. So we're going to use the f of x, g of x thing. So the derivative of this is going to be equal to the derivative of this, right?
Mhm.
Times the derivative of the inside function, basically. Yes or no?
You kind of lost me on that part.
Well, we're doing the same thing here that we did up at the top. We're saying that the derivative of, so we're using this thing that says if I have h of x equals f of g of x, then that's going to be the derivative of f of g of x times the derivative of g of x, right?
Yeah.
So if I have this function right here, so here, let me point. So if I have this function right here, I can say that's f of x squared is the g of x, right?
Mhm.
Then I'm going to say, okay, well, that's the derivative of this f of g of x times the derivative of the inside function, which is g of x, which is x squared, from up here.
Gotcha.
Does that make sense?
Yeah.
Okay. And then, well, what is f of x squared actually equal to? Because we remember, we're trying to find h of 1. So we want h prime of 1. So now I'm kind of ready to start plugging stuff in, aren't I?
Mhm.
So what can I, so basically this is f of 1 prime times the derivative of x squared, right? What's f of 1 prime?
-1.
So it's 3 times -1. So it's positive 3. So this becomes positive 3. What's the derivative of 2x?
Well,
I'm sorry, what's the derivative of x squared?
2x.
2x, yes. So this equals 6x, but we know now x equals 1, so the answer is 6. Okay. So I'm going to make up, we have a few minutes. I'm going to make up a really, like a long, like more than one inner and outer function so you can kind of see how it works. Okay. So let me just go back to another screen. I'm going to go back here because I have some space. I'm just going to erase everything and I'm going to make up a problem. All right. This is not going to be the problem I'm going to do. I'm going to say y equals, we don't have a lot of different functions, so I can't make it too hard. Let me see. Sine of cosine of tangent of 2x. Now, this is really hard to solve just by doing the f prime of g of x times g prime of x. This is very hard because there's a lot embedded in here. Do y'all see that? So I'm going to do it. I'm not going to even ask for volunteers because this is kind of hard. So I'm going to start with my innermost function, which is 2x. So I'm just going to say, let's let u equal 2x. Okay. And then I'm going to move out to tangent of 2x. And I'm just going to say, let's let v equal tangent of u. Does that make sense still? Yes, hopefully. And then I'm going to say, okay, well, that doesn't handle everything. I'm going to make another variable. I'm going to say W. Let's let W equal cosine of V.
Yeah, that makes sense.
Make sense? Good. And now I've gotten this, and now I'm going to go to my last one. And since the last one is Y, I'm going to say, let's let Y equal sine of W. And now I have a lot of embedded things, but it's pretty easy to take the derivatives of all that. Do you see that?
Yeah.
All right. So I'm going to say du dx is equal to 2. dv du is equal to secant squared of u. dw dv is equal to negative sine of v. And dy dw is equal to cosine of w. Does everybody understand what I did there?
Yes.
Okay, is there any questions before I move on? Because once I move on, it's going to get a little more complicated. Not too much, but a little more complicated. Okay, good. So now, what's my question? I want to know what dy dx is. And I can say, okay, well, that's equal to dy dw times dw dv. And that would give me dy dv, but that's not dy dx, so I have to continue. So I'm going to multiply that by dv du. And then that would give me dy du. So I'm going to multiply that by du dx. And now if I look at it as fractions, I can say, well, the dw's cancel, the dv's cancel, the du's cancel. And notice, look, I have dy dx, which is what I want to find. Is everybody still with me?
Yeah.
Yep.
Okay, good. So now I just plug it in. I mean, at this point, it's pretty simple because I have this is cosine of w times negative sine of v times secant squared of u times 2. And then I just keep substituting. So I know w is equal to cosine of v. And you can do it all at once or one at a time. So I'm going to do it faster because I know we have to get on with the groups. So w is cosine of v, but I know v is tangent of u, and I know u is 2x. So I can just plug it in. So w is cosine of v, and v is tangent of u, and u is 2x. Okay. Times, now I'm on, that's just, that was just cosine of w here. I'll change colors. So now we're going to do negative sine of v. I'm going to put this negative out front because I don't want it back there. And then I have times sine of v, but v is tangent of u, and u is 2x. Okay? And that takes care of that. Then we'll do this secant squared of u. So I'm going to multiply this by secant squared of 2x. And then I have this 2. So I'm going to rewrite this as 2, negative 2. I'll just write secant squared of 2x out front. And then it doesn't really matter the order. Cosine of tangent of 2x times sine of tangent of 2x. Now, I don't know if you can see how complicated this would be with the other method, but I don't think I could do it with the other method. I think I would make mistakes. What do you think, Andy? Could you do it with the first method, or would you use substitution for this?
I could either do it both methods. I guess I would prefer you in this case.
The substitution method, right? Because it would get you. I think
It
most people get lost in this if they didn't break it down like this. I think.
I agree.
Okay, so I think if you get something really complicated, then break it down. If it's something simple, it's fine with me if you just take the derivative of the outer function times the derivative of the inner function. That's fine. It works very simply that way.
Mm.
All right, so I'm done. Is there any questions about this? Okay, let's stop it here. Let me stop recording.